Hi everyone, welcome to another video where we take a look at another problem in mathematics, and we take a more careful look at the problem solving process and the kinds of approaches that might be useful to consider when it comes to trying to find a solution to a non-routine problem, a fairly non-routine problem. So in this video, I've decided to take a problem from, it's a book that I've used before, I think, Discrete and Combinatorial Mathematics, an Applied Introduction. This is the third edition, and the author is Ralph P. Grimaldi. And the problem that I've selected is from page 459, and it's problem number 9. So the problem is to simplify the following sum, where n is a positive integer. So it's n choose 1 plus twice n choose 2 plus 3 times n choose 3 up to n times n choose n. I think that's right. Yeah. And there is a hint. It says you may wish to start with the binomial theorem. So I always like problems involving binomial coefficients because there's they're fun to work with. I find them quite fun and interesting to work with, and it's interesting the kinds of relationships that you can determine. So first of all, we need to make sure that we know what binomial coefficients are. This is something that, from my experience, particularly with A-level students, A-level math students, they can kind of get into the habit of thinking that binomial coefficients are just something that their calculator tells them. So they just tap something into their calculator and it spits back a number, and this is the number that they need. And no doubt it is. But what they don't know, in a lot of cases, and much to their detriment, by the way, is how binomial coefficients, at least for positive integers, are defined or can be defined. So for example, n choose r is defined to be n factorial over r factorial times by n minus r factorial. Or alternatively, this is one of the things that we can do is we can cancel out some of the common factors in the numerator and denominator. So if you understand what these mean, these symbols, which I'll explain in a second, then you understand that the numerator and denominator here potentially contain common factors that you can cancel out. And you get something like n times n minus 1 times n minus 2 times n minus r plus 1 over r factorial. So we understand n factorial as meaning n times n minus 1 times n minus 2 times down to times 2 times 1. In other words, the product of the first n positive integers, and we take 0 factorial to be equal to 1. We define 0 factorial equal to 1. So I mentioned this in a previous video that we could choose 0 factorial to be anything. Theoretically, we're free to choose, but we understand this symbol to mean equal to 1, just because it's convenient for us as mathematicians to set it equal to that. Okay. Right, so once we understand what this means, then we're able to maybe start attacking this problem. So, by the way, guys, this is a fairly new YouTube channel. I've only got a few subscribers to this channel at the moment, at the time of making this video. I'd be really grateful if you'd subscribe to this video, tell other people about this channel that might find it useful, and give this video a thumbs up, give it a like, be really grateful. Also, feel free to leave a comment in the comments section if you've got any ideas about the kinds of things that you'd like to see videos on, that you'd like me to make some videos on. Please let me know in the comments section. if there's anything that you'd like to see done differently. At this moment in time, I've only got my the camera that's on my phone. I will be looking at some point to invest in some better quality equipment on which to record these videos, because I know that the videos are a little bit blurry at this moment in time, but that's just going to be the way that it is for the time being, I'm afraid. My background is in private maths tuition. I tutor mainly GCSE, higher, IGCSE, A-level maths, A-level further maths, and I specialise in providing tuition for those students who are looking to really reach their true potential, get top grades, for example, and potentially go into high-ranking academic institutions. So a lot of my students in the past, many of my students have gone on to top universities, for example, Oxford, Bath University, Warwick University, Durham, for example, Leeds University to study mathematics, physics, statistics, data science, philosophy, computer science. Have I already said that one? I can't remember. So if you are interested in developing your mathematical skills, and in particular your problem-solving skills, because it's problem-solving skills that really distinguishes those students that get top grades from those students who do not get top grades. So if you really want to develop your problem-solving skills, which is what my tuition really focuses on, is developing good, strong problem-solving skills in mathematics, feel free to get in touch with me. I'd love to hear from you. I'd love to have a discussion about your needs, your requirements, and how I can help you. With that, without further ado, let's get on with solving this problem. So now we know what the problem is that we need to solve. We need to simplify this expression. And we know what's meant by binomial coefficients. So a calculator, for example, is going to be of limited use. And beside the point, even if we could use a calculator here, it's not really what we need to be doing, okay? What I'm really trying to emphasize in these videos is the development of problem-solving skills. And you can only develop problem-solving skills by solving problems and solving problems yourself rather than outsourcing the problem to something or somebody else, okay? So yes, calculators can do all sorts of things now, like integration, differentiation, might even be able to deal with stuff like this at a certain level. But it's not so much the answer, so the simplified form of this that is really interesting to us at this stage. It's how we get there. What are the thought processes that we need to go through to get to that point? So that's what we're interested in. Okay, so when I first attempted this problem, the first thing that attracted my attention was the pattern that I see here. Try to pick up on certain patterns, okay? When you're solving a problem, try to pick up on certain patterns. So one of the patterns that I noticed here was that this number is always the same as this number, okay? Seems like an obvious thing, but let's have a look then. If I've got, for example, R times n choose R. I might want to investigate a little bit more closely what can I do with this expression. And this is why it's important for me to know either this or this, okay? It's important for me to know these because it gives me something potentially to do. It might not work, it might not be the thing that ultimately gets me to a solution, but it gives me an idea that I can start to work with and at least start to possibly get my foot in the door with a solution to this problem. So this is going to be equal to R times n factorial over R factorial times n minus R factorial. Okay, well, I know that R factorial is equal to R times R minus 1 times R minus 2 times da 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 da. So that means that there's an R in here that will cancel with this R. This was just me messing around. with the algebra at this stage. I didn't know that this was going to work, that this was going to lead to anything. It was just something that I felt I'd noticed up here and I wanted to have a go at. And this is important. I've mentioned this in previous videos. It's important for you to just go with your ideas. The worst thing that can happen is that you have no ideas, or that you have ideas but you refuse to do anything with them. You won't get a solution to a problem if in either of these cases. At least if you've got an idea and you're prepared to give it a go, it might work, it might not work. But if you're so scared that your idea might not work that you don't even put pen to paper, you'll never find out. So I didn't know when I set about doing this that anything was going to come of it. It's just I was prepared to give it a go. And this is what I see. There's an r here in the denominator that is going to cancel with this r. So that gives me n factorial over r minus 1 factorial times n minus r factorial. Okay? And at this point, something else triggered in my mind. So I can't remember which property it is. I think it's when you want to prove, for example, that the binomial coefficients are symmetrical in the sense that n choose r is equal to n choose n minus r. There's a certain trick that you can use when you prove this, which I'm not going to go elaborate on in this particular video. But it was the trick that can be used, that's often used in proving this, that I think it's that anyway, that kind of triggered something off about this. Now, it's not this theorem, it's not this property of binomial coefficients, it's just something that you do when you prove this, okay? That kind of gave me an idea. And again, it's listening to those ideas that you have, okay? The ideas might work, they might not work. So my idea was that I can write this as n factorial over r minus 1 factorial times n minus 1 minus r minus 1 factorial. Okay, why is that? Well, if we start with n minus 1 minus r minus 1, and I get rid of the brackets here, I get n minus 1 minus r plus 1, which of course is equal to n minus r. So I'm just writing this n minus r in a very fancy way. This is a very common thing to do sometimes in mathematics, is to I've effectively added 0 to this in a very particular way by subtracting 1 and adding 1. Other things that you can do is multiply an expression by 1 in a very particular way. This is kind of what you do when you find equivalent fractions. Okay, and you can generalize this idea. You can use it to great effect when you've got algebraic fractions, for example. Multiply the numerator and denominator by the same expression. Okay, so look out for opportunities to do things like this, to rewrite expressions in very particular ways. And now that you've seen me do, if you haven't seen this done before, now that you've seen me do this here, maybe try to bear it in mind and look for opportunities to do things like that in your own problem solving. Okay, so why is this useful? Because now I can write this as n times n minus 1 factorial over r minus 1 factorial times n minus 1 minus r minus 1 factorial. Again, at this stage, I'm still none the wiser really whether this is going to actually lead to anything useful. I'm just playing with the symbols. I'm just doing something. But what I see here is that this is equal to n times n minus 1 choose r minus 1. Aha, okay, so this could be useful. This could be really useful because it means that wherever I see this symbol, r choose n choose, r times n choose r, I can replace it with this symbol, n times n minus 1 choose r minus 1. That could be really useful for me. So let's try it out. Let's see if anything comes of it. So this thing up here, I can write as n choose, so it's going to be n minus 1 choose 0. Well, okay, 1, yeah, n times that, okay, yeah, n times n minus 1 choose 0, plus n times n minus 1 choose, well, r here is 2, so r minus 1 is going to be 1, plus n times n minus 1 choose 2, plus all the way up to, this can be replaced with n times n minus 1 choose n minus 1. Of course. Okay, so what we can see then is that we've got a common factor of n all the way across. N, take n out as a common factor, I get n minus 1 choose 0, plus n minus 1 choose 1, plus n minus 1 choose 2, plus n minus 1 choose n minus 1. So I'm pretty pleased with this at this moment in time. This looks like it's going in the right sort of direction. Again, there's still no guarantee that anything's going to come of it, but it's certainly something. Okay. So let's see. Let's get rid of all of that. So the hint what here, by the way, was, and let me get this right. What was it? You may wish to start with the binomial theorem. Okay. So sometimes it's difficult to fully understand when you're given a hint. Sometimes it's obvious what the hint is kind of driving at. And in that case, in my opinion, it's a bad hint. If the hint is too obvious, it's a bad hint, because it's kind of solving the problem for you, which is not, that's not giving you the opportunity to solve the problem yourself. Okay, and the whole point of problem solving is to develop your problem solving skills, not just to get the answer at the end. It's actually to put yourself through that sometimes quite torturous process of solving a problem, learning to deal with various difficulties that come up as part of the problem solving process. Okay, but this is a fairly good hint, because it doesn't necessarily make it clear exactly how. When it says you may wish to start with the binomial theorem, to do what? Well, that's what you've got to figure out. Okay, but here is where I would be maybe thinking about the binomial theorem. So, for example, let's say I've got the binomial expression 1 plus 1. In fact, no. Let's not make it so clumsy as that. X plus y to the power of n minus 1. What is the expansion of this in terms of binomial coefficients and things like that? It's going to be n minus 1 choose 0 times x to the power of n minus 1 y to the power of 0 plus n minus 1 choose 1 x to the power of n minus 2 y to the power of 1 plus all the way up to n minus 1 choose n minus 1 x to the power of x to the power of 0 y to the power of n minus 1. So this is just the typical expression for the expansion of the binomial expression x plus y to the power of n minus 1, the typical formula for the binomial expansion of the binomial expression x plus y to the power of n minus 1. So anybody that's done GCSE Maths should know this. If you don't, learn it because it's useful. Okay, so what happens if x is equal to y is equal to 1? Then here we get 2 to the power of n minus 1 is equal to, well, all of these are going to be, that's going to be 1, that's going to be 1, 1, 1, 1, 1. So what I'm just going to get is the sum of the binomial coefficients. So in other words, the sum of the binomial coefficients here, n minus 1 choose 0, plus n minus 1 choose 1, plus da 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 da, n minus 1 choose n minus 1, is equal to 2 to the power of n minus 1. Great. That's exactly what I've got here. So this is equal to n times 2 to the power of n minus 1. And when it says simplify the following sum, I think that's what we need. I can't really get much simpler than that. You can verify this for the first few values of n if you want to. I think I did do. Maybe I didn't. I don't know. Yeah, so I think it works for the first few terms if you verify it, first few values of n. But just that doesn't mean that it. I've checked it for the first few terms and verified it. It doesn't mean that it doesn't work for the terms after that. It just means that I haven't checked them. But it definitely works for the first few terms, as you would expect, because, well, I don't see anything wrong in what I've done here. So if the steps of your solution are correct, understands that the outcome is correct. Okay, valid logical steps. If you've got valid logical steps at each stage in your solution, this can only lead to a valid logical conclusion. Okay, so if you trust the logic is correct, you trust the logic, then you have to really, logically, you have to trust that the conclusion is correct. Okay, so I can't see anything wrong with the steps that I've taken here. So I'm happy with the logic. Therefore, I'm happy with the conclusion that this is true for all values of n, a positive integer. So just before I finish, don't forget, hit that subscribe button, give this video a like, let other people know about this channel, and I'm going to finish this video here.